We want to now look at that given that different values of S lead to different steady states, what is the optimal savings rate? So now for this, we'll consider two extreme cases for the savings rate. Because we know the savings rate can take values between 0 and 1. So we'll consider the two extreme cases, S is equal to 0 and S is equal to 1. Now, if S is equal to 0, then capital per worker in the steady state will be 0 because we know we find the capital per worker in our basic Solow model by setting SFK equal to delta K. Right, so if S is equal to 0 from here, if we solve for K star, that's equal to 0. So if S is equal to 0, capital per worker is equal to 0 in the steady state. And so output per worker will also be equal to 0 in the steady state because output per worker is just a function of capital per worker. Y star is Fk star. If K star is 0, then Y star would also be 0. And then consumption per worker would also be 0 in the steady state as a result of this because C star is 1 minus S Y star. So if Y star is 0, C star is also 0. So S is equal to 0 implies that steady state consumption per worker, C star is equal to 0. We can illustrate this graphically as here, where we can see that if individuals don't save at all, S is equal to 0. The investment or a savings function SFK is just coincides with the horizontal axis because S becomes 0. So this just coincides with the horizontal axis. So as a result of this, K star and Y star fall to 0 because we know graphically K star is at the intersection of the depreciation line delta K and the savings function SFK. This intersection occurs at K star is equal to 0. K star is 0 and Y star is also 0 because when you plug in 0 in your production function, you're getting Y star is equal to 0. So even though individuals are ready to spend everything they earn because S is 0, but in this, they earn because there's no income in the steady state, that leaves nothing for consumption in the steady state, right? So graphically also we can see C star is 0 because graphically C star is the vertical difference between our Y given by a production function and our savings investment function value at K star. So at K is equal to K star, the vertical difference between FK, I output, and our savings or investment is equal to 0, right? This vertical difference between them is 0 here. So C star is graphically also seen as 0. So we can see when S is equal to 0, so K star is 0 and hence Y star and C star is 0. Now at the other extreme, if S is equal to 1, the level of capital per worker in the steady state and this output per worker in the steady state will be maximal. But since all income is saved, consumption per worker in the steady state is 0. Because C star is 1 minus S Y star, so when S is 1, C star is 0. So S is equal to 1 also implies C star is 0. This is illustrated in the figure on the right, where we can see that if individuals save all their income, then their production function, IFK, and their savings investment function, SFK, coincide, right? They're the same, basically, curve, right? Because over when S is equal to 1, then Y is equal to FK is essentially equal to SFK. Then our production function and our savings or investment function coincide. As a result of this, K star and Y star grow at the maximal level. But since all the maximum income must be saved, nothing is left for consumption. C star, like we said, which is the vertical difference between FK and SFK at K star, will be 0. Right? So whether S is equal to 0 or S is equal to 1, we've seen C star will be 0. So somewhere in between 0 and 1 is a savings rate that will maximize steady state consumption per worker. And this savings rate is called the golden rule savings rate. And associated with this is the golden rule level of capital. So this argument is illustrated in the figure below, where we're plotting consumption per worker in the steady state on the vertical axis, i.e. C star, against the savings rate on the horizontal axis. We can see that if S is equal to 0 or S is equal to 1, then C star must become 0, and we've looked at the logic behind it here. And somewhere in between 0 and 1 is a value of the savings rate, which is S gold, which maximizes steady state consumption per worker.